So anyway, let people come. So we will start. So this one, of course, the title tells something. We will basically take the general background of IoT and few other peripherals. So not exactly that we will be talking about the uploading the data to the cloud. So we will see what we mean by IoT, what type of impact IoT will have, what type of impact IoT will have on the different applications, requirement, basic building block, what type of embedded processing device we need to have for making IoT based systems, gateway, hardware availability, software requirement, communication topology, little bit of the protocol, wireless connectivity, cloud service, security, and so on. So as we know that IoT is now becoming very, very popular, but actually IoT, when it started, the name was given by IBM in 1999. So almost like 8, 9, 10 years, people were not too much gave attention to IoT. So Internet of Things, so effectively what it makes, anything anywhere in the world can talk with each other, and that's happened basically through internet. So that's why internet connectivity is fundamental for making IoT happen. And when you talk about the things, it's not so much important about thing. What is important is that what sensing we have, what we are sensing, isn't it? So even if you say that a chair needs to talk, but chair doesn't tell that I am a chair. Chair might tell that somebody is sitting on me, isn't it? So that type of things are important. So when we say Internet of Things, that means things are connected to internet, they actually tells us something. And it should be anywhere, it should be any place. So in order to have that, you need to have the availability of internet. That's the very, very fundamental things. So sometimes you may actually find difficulty of having that happen in many countries unless you have internet available everywhere. By next year, we have at least 2 countries in the world who decided have the internet everywhere in the world. In that country is Japan and Taiwan. So if you go to Japan, you just have your iPad, you can go any parts of the world or any parts of Japan, you can have internet, and similarly Taiwan. But if you can understand that in order to have that happen, somebody has to pay for it, isn't it? Somebody has to pay for it. So internet infrastructure is not a very simple thing. So Japan decided, because Japan is going to have the Olympic 2020, so they wanted to have the internet because they want to attract people to come to Japan. Taiwan, they have huge amount of money, they don't know how to spend, they decided that they will have some money spent on internet. Okay? So it is the situation. So India unfortunately have more priorities. You understand? Last year I applied a funding with IIT Madras. It was on food security, because New Zealand and India, they had the 2 proposals. So our proposal on food security, our proposal was rejected. The proposal who got is on food generation. You understand what I want to say? Because in India you need food, not for the quality of food. So quality of food will come maybe another 10, 15 years time when everybody will have food. You get the point? So that type of situation we are in. So maybe internet everywhere in India, you may have to wait 20 years. Okay? I am not sure, but right now at least what we can see is that some cities, okay, Prime Minister constituency Varanasi is becoming a smart city. When we define a smart city, so I will have a lecture on 1 hour sometime in 30th maybe, we will see that smart city means internet is must, because you want to see everything and internet only gives you that option. So at least in India now few smart cities, so time will take care of it, but you don't expect everything happen overnight. Okay? So things will happen, but it will take time. So IoT fundamental thing is everything will be connected to everyone, and that's happened through internet. So, if you see, this is the kind of structure a IoT system will have. When we design something, when we develop something for IoT, we may not have everything, but in general IoT will have this. So, anything in the world will be connected. Now, in order to have that, you need to have these things connected to smart processor with wireless connectivity. Now, it may not be wireless, it will be having some connectivity, it can be wired also. Okay? So, inside the home environment, you may have many things connected to wired, you do not need wireless. So, it can be wireless as well as wired, but it will have the connected. So, they will be connected to local network, There can be many networks which comes under local network. Okay? All the Bluetooth, Zigbee, Wi-Fi, wireless HART, all these things can come under local network. 6LoWPAN, IPv4, IPv6, all these can, and then you need to have the gateway. So, gateway actually coming as the interface between the internet, which we talk about the internet cloud, and your system. So, in many systems you may not have gateway, but in general gateway is kind of essential element in IoT. Now, when I say that you may not have, suppose you have a embedded processor and that embedded processor itself has the connectivity to internet. You install that embedded processor, or it's called not embedded processor, we call IoT enabled embedded processor. You install somewhere to measure something, it measures something, directly upload the data in the internet. You can have the distributed monitoring of that way by cloud. The cloud connects them together. So, one of my students actually developing that IoT enabled embedded processor, and that's for Bangladesh. We want to monitor arsenic level. Okay? So, our aim is at the cloud level, we want to get a semantic web. So, it's a map where you can see in your network, in your mobile phone with little bit of big display, that what is my arsenic level. In New Zealand, we are doing for the nitrate. So, the same thing, because I have to develop something in New Zealand, so we are going for nitrate. So, we are developing the nitrate sensor, but aim is to have a processor which is IoT enabled processor. So, then you do not need the gateway, but of course, you can also say that gateway is there, because the processor, when it connects to internet, it has to follow some certain kind of standard, certain kind of hardware. So, that may be the gateway. So, actually gateway you cannot take it away, because it is the interface between the IoT and your system. Now, when it comes to internet, then you may say actually what it does. Internet have got huge amount of data, where they are stored, what they are used for. So, that is sometimes beyond our imagination, and those who are doing research on the cloud computing, on the big data, they may actually deal better than the engineers. Okay? So, we do not actually do too much on that. So, I can tell you one example. Somebody came to me and told that he gets 80 gigabyte of data in 1 hour. Can you help them to analyze 80 gigabyte? How do they get that? So, they have a drone, okay, and it has got a high intensity camera. So, they allow the drone to fly on some agricultural land and collect the image in 1 hour, 80 gigabyte. They have memory, sufficient memory for that. After 1 hour, they take away the memory and they want to analyze. So, we told, see, we can analyze some few kilobytes, few hundreds of kilobytes to few megabyte, we can do, not 80 gigabyte in 1 hour. So, that is the problem of big data. So, if anybody has got any idea with computer science background, how can I analyze 80 gigabyte of image, You understand the problem? So it actually goes to different domain. So that type of problem is coming up because availability of different systems gives you huge amount of data. So when the data goes to the cloud, then it goes to completely another domain. And if you have some specific application in mind, what you could do with those data, you may have some kind of idea what you can do. But otherwise, it's very difficult to say what you will do with those data. So all the data goes to the cloud. Definitely they will have some access and some analysis, but we need to know. So usually we always talk about the business, isn't it? Business data analytics, what they will do with those data, we don't know, but the business people, they might have some use. So it's a lot of new research will come up in that area with time. Already many people are working on that, but there will be lots to come. So we'll see with time. So what will be the impact? IoT already started different types of applications, which sometimes we may not say IoT, but it is coming under IoT. IoT is a huge umbrella. Everything can come under that umbrella. So it's very difficult to argue whether it is IoT, it is not, it can come anything under IoT. So if you see some of the applications which are already happening, like this one. In residential applications, home automation, okay, you can be somewhere else, you don't need to be at your home, but you can control all the appliances using mobile phone. But you do not use the mobile phone using telephone lines, you use IoT, so it's basically free, you don't need to call as such, you use internet. So you go for accessing the internet and then go to your system. If your system all are connected to internet to be done that way, you can control. People actually take the alarm systems. So earlier, if you think of the way alarm system works, now because of IoT, they work in a different way. You don't need to have the telephone line from your home to that particular company. You can, but of course, then the issues of that security comes into picture. So whether the system is secure enough. So, but it is happening. So this type of things is already started working. If you think of the energy way, now smart meters, like 2 years back, still 2 years back in New Zealand, one person from the electric company used to come to our house once in 2 months. So we have to give the electricity expenses 1 month called estimated, okay. So they charge you based on last year expenses, and then another month is the correct. So they send a person every 2 months and they used to get the reading and they charge you. So 1 month estimated, 1 month actual. So estimated means they don't send anyone, they just save money. But now nobody comes to our house, so they replace the meter by smart meters, okay. So they get the reading from their office and they send the bill every month, actual bill. So this is one of the applications of IoT. But few years back, you may not have actually defined it as an IoT enabled system. You understand? You thought, oh, okay, it's just the communication between that guy, that house to that company. But actually now it's all IoT. So that type of things already now in our life. Question is whether you will use it or not. When I allowed permission to my house, if I don't give, then what they will do? They will say, okay, fine, I will now give you estimated reading for 11 months and then 1 year actual, and they will charge you more. You understand? Estimated bill means based on last year, so you can actually pay more. So whether you want it or not, that maybe you need your permission, but ultimately you will find that people accept, isn't it? People accept. And that was one of the reasons we will find that in future there will be issues. There will be issues of privacy, security, but at the end of the day you will find that people accept. People accept. So things will be different in future. So this is the thing. Industrial, one of the things now telling the industry people are telling that IoT will revolutionize their operations, and they don't say IoT anymore, they call IIoT. So, industrial IoT. Okay. So, especially the China, they are now putting lots of money on IoT. My colleagues, my friends who are in China, they are, if they could actually come up with project IoT, they get a lot of money from the Chinese government. So, IoT is now becoming a big word, but industry, you have to have an industry with you to get the money. Industry says this is not IoT, it is industrial IoT. That means IoT specifically for industry. So, that is the way things are going. How they will make the things is very difficult to tell, but they are telling all the control, automation, human machine interface, all these things will be using internet, and that can change. Healthcare is already, as I said, that we are actually working on the healthcare. IoT is already there. So, effectively what happened? You will be allowing the system for distributed or not distributed, remote monitoring. Okay? Somewhere you don't need to go, internet will give you the complete picture. So, that type of things will happen. So, it's like remote. So, because of internet it is possible. So, patient monitoring, elderly care, telecare, smart health, all these things will be under IoT. In automotive applications, few years back in America, in Michigan state, they made a prototype trial using IoT. They don't call IoT, they call Internet of Vehicles. Okay? Internet of Vehicles. Basically what it does, see in US, you always see in Indian TV, whenever in US somebody, because they have the permission to keep gun in their pocket because they want to save their life by themselves. They don't think that government can save their life, so they have to save their own life by having a gun. And sometimes they want to play with the gun just to kill people, isn't it? So, that is one of the common thing we see in Indian television. So, we see also in New Zealand, it's not only in India, because when America is the best country in the world, no, something happened, we have to know. But that is nothing. In US, maximum people die on road accident. Okay? Maximum people die on road accident, nobody knows. And I told you, no, because there was a survey in US that US people, they like to go to travel long distance for their work, okay, 1 hour. There was a survey that would you like to go by private bus or private vehicle, not a train or something, instead of your private vehicle. More than 90% told no. Okay. Why? Because they told out of 24 hours, the travel time, I go 1 hour to my office, I come back 1 hour from my office, that's the time I get for myself. You understand? Out of 24 hours, that's the time for myself, because when I go to my office, it's not my time. All my colleagues are there. When I come to my home, my family needs me, so that's not my time. So, I get my time only when I drive. So, it's a different types of people, isn't it? So, that's the way things are. So, they make, in some cities they call carpool. You understand? Carpool, because that lane can be used only when 2-3 people use the car, not only 1 people. If you go by yourself and use that lane, because that lane is empty, you will be fine. So, helicopter will see and then fine you. So, that's US. So, in Michigan state, what the government decided, Michigan state government, can we reduce the accidents? Can we reduce the death by accident? So, they took 3,000 vehicles of the city, combination of all, trucks, cars, even small cars, all types of vehicles, 3,000 vehicles, and all these vehicles have sensor. Those sensors basically measure the speed of the vehicle, location of the vehicle, and few other things, not too many things. One is the locations, one is the speed, derivative of the speed. Those data goes to the server. Server decides all this processing and feeds back the driver that okay, you follow this particular road is empty, relatively empty, and you go at this, all these things. After 1 year trial, they actually reduced by 34% the accident. But it's a huge amount of infrastructure required to have that type of system in practice. So it was not possible to continue, but that was one already done. It was happened in 2012, 2013. So it's called Internet of Vehicles, okay? But it's basically applications of IoT. So if you have those type of things, you can understand that it is possible to reduce accident. Now you may say 34% is not too many, but you can save at least life of many people and consequence other things. So it's a huge impact. So this is one thing which will be very important. And lifestyle, now in many countries, I know in India whether you got that fit band. Do you have some? Because in New Zealand almost everybody, especially the ladies in our office, everybody has got that, and they go, in the off time, and they say, compare, oh, I have 6,620 steps today. So in India it will also come. So last year I went to China because in New Zealand this is costly. They're around $400.
One of our faculty already is counting these things.
In New Zealand it's $400. Now I think a little bit cheaper, but in China it's quite cheap. So when I went to China last year, my son told, Baba, can you please bring one for me? He's 11 years old. So I brought two, but that was not good. That was not display. That has to see from the computer. Okay, so the first day when I brought it, okay, he has to download the apps and set it. Oh, it was working fine. So he used that and slept. In the morning he got up, how much energy I spent. But it doesn't work because it's no, accelerometer is there. No, if you don't know, you will find accelerometer doesn't work. He's sleeping. So still, whatever you have brought is not very good. It doesn't work in the night. It does not tell me how much energy I spent. So it's a very crazy thing. But that is happening, and you cannot actually tell because the people at some stage they like to spend money on healthcare, and they are very, very careful. So those things are all connected to internet. You can see, in computer, and if you have a profile, you can set up the things. It will go to your profile and save the things there. Gives a lot of graphical things. So you can. So that's quite interesting. And one of the things, business people, they always take that because the gaming industry is a huge industry. In Germany, there is an institute of gaming. Okay? So you can understand. So people just go to the gaming machine and they spend money. They spend lots of time and money. So that's one of the things. So a lot of people, they actually are spending money on the lifestyles. So IoT is becoming booming there. So lots of wearable sensors, gaming, fitness. So IoT will have huge amount of impacts on different parts of our life. So this is one of the just sketch for the home. It can do everything, okay. Now you may say that most of the things are kind of isolated to each other. At the ground level, you will find they are all isolated, but at internet level, they are all connected, okay. So that's why you will have this connectivity through internet. So if you see, this is a typical house, not typical of course, it can be the Hollywood actor's house, but you will have everything. So whether you have your garden, lawn, sprinkling is done, of course you may say I can set up at some particular time, but then the time will change. Like in New Zealand, we have almost 16 to 17 hours daytime, now of course slowly reducing. So during December, January, we can see the sun very early, we can see the sun till 9 o'clock, okay. So the day is very long. But if you go in August, September, we see the sun only for 5-6 hours, okay. So even like 8 o'clock is dark and 4:35 it becomes dark. So you understand? So if you set up the system based on a fixed time, you actually don't do efficient system. So you have to have that real time things, and depending on many things it can change. So you sprinkler system in the lawn, gas, water meter, e-meter, smart appliances, pool, setting the temperature and this thing, and then heating arrangement, thermostat, lighting, security system, garage door. You take power because you need a lot of power, and then you have to have a gateway. So all these things will be there when you talk about a smart home. Okay, it's not only on particular things. If you extend it to a smart building, then you can have lots of other things like car parking and floor arrangement. So here, Internet of Things inside the home. So your all the slide switch, they can be internet enabled. Okay, so you can sit down on your sofa, you can use your mobile phone, and you can switch on and off. Sometimes there was a crazy thing came that they need to be voice controlled. Understand? They need to be voice controlled. Actually, we did something on the voice control. Actually, voice control can be very, very useful for some applications, especially if the person has got problem of moving. Okay, he is old, may not be able to move. Then voice control things can be very, very useful. So few years back we did a project on voice recognitions, and it's quite useful, especially a country like New Zealand is the country of immigrant. Different people accents are different. So how you can say on, okay, light on, light off, okay, but how actually that particular two words of different ethnic background can be recognized by the voice recognition system can itself be a research problem. So we ended up with only 79% accuracy. Because we had in New Zealand we have got people from Middle East, people from Africa, people from America, Latin America, Pacific Island, and Asian countries. So it's different accent. So it's quite interesting problem. So voice recognition system, there is a crazy thing. You can say you do not need to be the old people, but still you can say after whole day's work I am very tired. Light should be dim. Okay, light will be. So this type of system can be, it's possible. It's not that it's impossible. Whether implementation will be done at cheap price, that's the question. So it can. So now what are the things you need to have in order to implement IoT based system? Now as I said, the things means not things. Things means some sensing, isn't it? Things means some sensing. So you will have fundamentally some sensor. Okay? They can measure anything, whatever you like, but you will have some sensor. Then you have some processor. So you will always have some kind of microprocessor connected with the sensor. Then they are connected either wired or wireless. Sometimes there is a debate. Sometimes there is a debate that if you talk about within the home environment, within the building environment, can we actually use the power line as the carrier? Okay, there is no issue. You can always use the power line as the carrier, but then you have to have some extra interfacing things. So it should be in the front end as well as in the other end. So that's the issue, but it can be. Then if you go for the outside environment, in the outside environment, always you think of the problem, how do you extend the lifetime of the node? So you have to deal with the energy harvesting option, and then of course security. So security, even though we say we cannot actually make the system secure, but that's not the end. You understand? We can always argue, but security is must. Okay, security is must. So these are the fundamental components of any IoT based systems. So if we represent them in the block diagram, so you have the sensor, embedded processor, you have the connectivity to the internet, and then the security. Software play a huge role in IoT. Software plays a huge role in IoT. Actually, it is very interesting. This semester in our university, we have started a paper on IoT. okay, and I was not. Oh, it's recorded, but it's okay, doesn't matter. I was not part of that. So computer science department started that, and they don't care about the sensor. Okay, they don't care about the sensor. So I was interacting with my colleague that, so software is a huge part, but software data, when the data comes from the sensor. So if you actually take out that part, it will not be a complex system. So that's the thing we have to keep in mind. But software is very, very important in IoT. Okay, you may say if we actually weight software versus hardware, I will say that maybe 20% hardware, 80% software, but you have 20% which you cannot take out. So unless you you provide the actual environment, the students may not be able to follow what it is. But software is very, very important for IoT. Okay, so now we will see some of the systems which are already existing. If we provide umbrella like IoT, they can all come. So you will see these days you can have the fitness equipment, you can see the display, but people may not be happy. After 1 hour exercise, they may actually see how I have done. Can I improve it better for next week? You understand? So they want the data recorded. Of course, you may say I can record it in a memory stick, but then I have to get it, taking it out, see it in the computer. It's not. I don't want to do that, and I don't have the expertise to do that. So I can just go to a website and see. So it's now connected. So all these things which are actually isolated device with us for last so many years, now they are all connected to IoT, to internet. So here if you see the parameters what we have for IoT enabled systems, we have the sensors, we have some kind of control if we want to do, we have some data processing, wired wireless network, and you need the power to manage. All these things you are connecting to internet. So that's the internet side. So you are connected to internet where it is going through the gateway. So now when you think of making your IoT, and hardware is fundamental, sometimes you do not actually make your system based on one processor. Because if you think, quite a few things are involved. You are getting the data from the sensor, you are collecting the data, you are analyzing the data, and then you are making the format, you are now following the IoT protocol, you are uploading the data. Now your processor, if it does everything, you will not be able to do anything on real time. Okay? So in IoT applications, when you come to hardware, you suggest, it's not that you must, you suggest that actually can I divide the work? One processor can deal with my data coming from the sensor and processing, another processor just connect with the network, and that's what the things happen now. So in our lab, when we are doing that embedded processor, we are going for 2 processors. So usually the processor which is connected to network, they should be little bit bigger, okay? But the processor which is dealing with the sensor, they need not to be so big. So you will have one processor which deals with the sensors, other processor which is connected to internet. So this is a 16-bit processor and this is a 32-bit processor. This is the general architecture of a IoT based system, okay? A IoT based system. Of course, as I said, I mean you can always argue that that's not the best architecture, you may have something else, you may not have 2 processors, but at the end of the day you will see that how is my performance is affected. So always your one processor problem is they do the sequential things, they cannot do the parallel things. So the one thing you do, then you go for another thing, there is always a time delay, and that latency you need to take into account. So it is better if you divide the work and you can do some work parallelly. So in our lab we try quite a few embedded processors, and as you know that we cannot fabricate on our own, so we have to rely what is available in the market. So we do that way because we don't fabricate on our own. Okay, we can fabricate sensor little bit, but that's not. It's processor things, you have to rely on the market. So we now compare different platforms and which one is the best. So that type of thing. So Arduino one of the platform which is quite cheap. I don't know how many people use Arduino. So it's very cheap compared to other platform available, isn't it? So this is one of the, and also very simple because it provides lots of libraries and softwares for integrated development environment where you can use. So it's quite useful. So it has got two processor. One is ADMEGA, which connects the sensor. Another is the Atheros, which actually connects the network. I'm not sure how much is the cost. I think not more than $20 New Zealand dollar. So effectively in Indian rupees less than 1,000 rupees. How much you pay? Yeah, so it's not very expensive. But on the other hand, the other one, Intel Galileo. Have you heard of Intel Galileo? So Intel Galileo actually came up with specifically for IoT applications. Intel Galileo. So Intel Galileo is quite expensive, like $100 for one, and without any wireless part. Okay, wireless part you have to go for separate. Okay, so now gateway. So gateway basically is the connection between the two part. One is the sensor part, another is the internet part. And what usually happen, because you cannot, because it's something coming from the business, you cannot actually say I only want to use this. Because of that, IoT becomes more complicated. So if you see in this particular area, there are many wireless protocols which are existing. Some in for the commercial application, some for the residential application, some for industrial applications, and you want to use them all. So the gateway becomes very, very important. So here you see Bluetooth, Zigbee, Z-Wave. In UK there are many people who work on the Z-Wave. Wi-Fi, I do not hear many of the things. Dash 7, ISA 100, HART, wireless HART, N-Ocean, wireless MBAS, Ethernet, Modbus. I don't know, many of the things you do not hear even, okay? But they exist. Some exist in industry, some exist on specific applications. So IoT wants to take everything, and that's why the gateway becomes very, very important, because gateway basically takes anything and they want to put everything in the internet. So the software part, as I said, is very, very important. Software, they actually take the protocol, they have to convert it to IoT, they have to switch and route, they have to introduce firewall, they have to introduce security. Of course, they need to have high-end processor. So those are the elements you need to have in any gateway system. Now, one of the problem which you will find that if you actually do research on gateway, you may not be able to do anything on the hardware, isn't it? Because hardware is some kind of standard. So you can do something on software, especially the hardware part more complicated unless you have a fabrication facility like Intel or other big companies has got. You cannot just do little bit of hardware fabricating some little things. It's very, very hard, and you cannot do putting the different components making a hardware, which will be very expensive, okay, and not efficient. So it will be quite hard to do any research on hardware based system for that type of application. So maybe the good way to go is to go for the software. So this is the complex situation for our IoT applications. So you have got all these things available, you want to take them, and then that's the need of the gateway, and then you connect them in the cloud. Here also you will find that there are many protocols available, okay. Some of the protocols you may use, and there is nothing called standard IoT protocol, okay. At the moment there is nothing. We may have something in future, we don't know when that future will come, at least not very quickly, you understand, because there is a huge amount of influence from big business body which will not allow to have a standard protocol very soon. So this is the Intel Galileo board which you use. So anybody has got interest, you will see this website and you can have a look, okay. I am not asking you to buy, but you can have a look. One of the advantage of this type of processor is that they are relatively fast, so it operates at 400 megahertz. so which is quite fast. Like if you see Arduino Uno, it operates around 25 megahertz, so it's not very fast. But the problem this guy have done, they have come up with a good idea, but they did not add the wireless part, which is a pain. Okay. Otherwise, it's quite good, and they give lot of example problem. They give lot of libraries, which is very, very useful. So one is Intel Galileo, another is Intel Edison. So there are two different boards. We use Intel Galileo. Actually, you got some of the boards free. You can always get free, but problem is when you make a system, you cannot have only one board. You need few more. So you don't get so many free. Okay, so in our developed system, we try to compare the facilities provided by different boards. So we use Intel, we use Arduino, also we try to use some other board just to compare which one can provide a standard platform. So these are the off-the-shelf available, so you can actually use without any problem, and many gives you some facilities, especially like Arduino integrated development environment, which are quite user friendly, and lots of libraries are available, and they also give some kind of instruction how to make a system. I can tell you that my student who is working on this, he is from Bangladesh. He was completely different area. Okay, I mean he did not have any idea, so he came to me. Okay, whatever I give problem, he will take it. That type of situation, okay, which I don't like though. But sometimes you cannot tell the students, oh, okay, it's the responsibility of the supervisor to give the problem. So I told, okay, fine. So we go for, because we are working on IoT, we go for IoT enabled platform. And if you think of that wireless network at the moment, even if you use Wi-Fi, it's a range of 5 kilometers. That's not enough for a country, isn't it? So for a country, you don't go for any kind of wireless network with that type of system. So it's the best way to go for internet connectivity. So that's the reason we thought that, okay, let us make a IoT enabled platform which can measure and put the data directly to internet. So that's why we thought, okay, what is the problem? Arsenic is a big problem in Bangladesh. Not only Bangladesh, it's West Bengal too, but Bangladesh, so at least he can convince. Okay, he is a self-funded student, keeping that in mind that if we can get some scholarship at some stage from Bangladesh government, telling them, no, we are doing something. But he cannot do everything in New Zealand unless we say it's a New Zealand problem. In New Zealand, nitrate is the problem. So effectively, if we target the sensor, one sensor developed for nitrate, changing the sensor developing for arsenic, other things can be the same. Okay? So that's what we do for this project. So I told him, actually he started from scratch. He did not have any idea. He spent a lot of time to learn the things, and now he made system with different sensor to check the other part is working or not. So that's what I want to share. So sometimes you can start from the scratch, but you could actually pick up. So it's not a, you have to give some effort, and you have to make your goal and target very, very clear. So this is I am showing you because you may actually look into that how it works. So Arduino Uno, if you go to their library, it gives you a lot of sample program and also gives you a lot of libraries which you directly can use. And that's very, very useful when you start writing something. I always feel like I mean, of course, I don't remember all my university or childhood days, but few things you remember when you written a very sample program and you execute it, it works, you feel very happy, isn't it? You always get extra enthusiasm, no? So that's important. So when you do something, it works. So that type of libraries actually help a lot. Otherwise, you do lots of things you don't know what is going wrong. And in the university days, if you are a PhD student, you will be very lucky if you get somebody to help you, isn't it? I mean, if you work in a group, you always feel happy that somebody is there to discuss with you. But you may end up with a supervisor, you are the only student. such an unlucky guy you can be. You will curse your supervisor day and night, but nothing will change. So sometimes it's really, really important to have a group, big group, so that you can discuss and this thing. So this type of library program and this thing very, very useful. So as you see here, they have lots of built-in example. Okay, they have a lot of built-in example. How do you deal with the basics, some basic program? How do you deal with the digital input? How do you deal with analog input? How can you make your system communicate? I mean, sometimes you write a program, you want to send it to USB port or somewhere, you don't know, you're stuck. And you ask, your supervisor doesn't know, because I don't know anything, isn't it? That's what happened. We can always tell from the top, but we don't do actually hands-on. So sometimes you come to the supervisor, you want some help, and the supervisor thinks, bloody guy, when he will come out of my office, isn't it? Okay? So a supervisor, he just tells blah, blah, blah at the top level, but the students doesn't want to listen. He wants some real help. Okay? It's the problem. So sometimes if you have this type of system, makes the things very handy. I am not sure whether everybody who are faculty with I mean, I am telling my situation, okay? So again, I mean, when you write the program, you try to access the hardware. It gives you some other libraries where you can access the hardware. So here you see they can access the Wi-Fi, they can access any kind of stepper motor is there, SPI bus, some serial communications, servo motor control. So this is quite useful. I mean, I am not telling, I don't get any money from Arduino Uno to promote it, but it is useful that if you get some kind of environment which actually push your work further, really, really useful. You know? Like Intel Galileo, we got free some of the model, we got 5 free, but I don't see that we can use those. So they also suggest that you use Arduino Uno, because this environment is actually quite useful. So maybe very, very useful if you do that. So also you get lot of extension program, and it allows you, you can see that they allows you .c, .cpp, and also header file .h. So it actually allows you to use multiple types of subprogram in your sketch, in your main program. So you can develop the program as like part of parts, and then you can add them together. So when you do that, you have to go for the sketch, main sketch, but otherwise you can do multi-file, different things in different subprogram, and then you can add them together as a main sketch file. So you have to go for Arduino.h. Yeah, so then that is actually help you to make the main program. And then once you do that, you have to, your main program written, at the end you have to make the executable files so that it goes to your microcontroller board for the operations. So the build process, so your target is the microcontroller board and the build process. So you have to give the path like that, and then you have to upload.